It says a glass beaker has a mass of 50 grams. A liquid of density 1.8 grams per centimeter cube is poured into the beaker until it reaches 200 centimeter cube mark. So we can see that we are given with the mass of the glass beaker, then we are given with the density of the liquid, and then the volume of the liquid reached is 200 centimeters cube. Calculate the total mass of the beaker and its contents. So now we have to find the total mass, which includes the mass of the liquid and also the mass of the beaker in which it is poured. So the formula which relates density, mass, and volume would be used here. So I'm writing rho is equal to m upon v. So mass would be equal to the product of density and the volume. The density of the liquid is 1.8. The volume of the liquid is given to be 200 centimeters cube. So answer is 360 grams. And since we have to find the total mass of the liquid, so for that we would be adding this mass of the beaker in the answer. So the total mass is going to be equal to 360 plus 50 for the beaker. So the final answer is 410 grams, and we would be writing 410 grams in the answer space. Now the next part says the center of mass of a meter rule is at 50 centimeters mark. State what is meant by center of mass. It is a point where the mass of an object appears to be concentrated. Or we could alternatively write as or where the object is balanced. Now note down that this word appears is very important here, and it has to be included in the answer. The next part says the meter rule is placed on a pivot. So this is the meter rule that we are talking about, and this is the pivot on which it is placed. The tip of the pivot is under the 80 centimeter mark on the rule. So this is the 80 centimeter mark, and under this mark the pivot is placed. The beaker with its contents is then placed at different positions along the rule until the rule is balanced. Now this beaker was placed at different points, and at the moment it is placed at a point where the rule is balanced. Since the center of mass of the rule is to the left of the pivot, so the mass would be acting in such a way that it would be trying to rotate the rule in the anti-clockwise manner, and this beaker is now providing a clockwise moment such that the both moments are balanced and the rule remains in its position, so it is balanced. Figure 1.1 shows the arrangement with the rule balanced. So now the rule is balanced. Remember, when something is balanced, it means that the clockwise and anti-clockwise moments are equal, so it is not turning in any direction. And secondly, the upward forces are balanced by the downward forces for that particular arrangement. One side of the beaker is at 84 centimeters mark and the other side is at 92 centimeters mark. So this is the side of the beaker which is 84 centimeter mark, and this is the other side of the beaker which is 92 centimeter mark. So it goes on to tell us that the width of this beaker must be 92 minus 84 equals 8 centimeter, and the center of mass for this beaker must be 4 centimeter from each side. So this distance is going to be 4 centimeter, where the center of mass of the beaker would be located. Now what we have to do, we have to calculate the mass of the rule. Now since the rule is balanced, so I'm writing for a balanced rule, or the principle of moments would be used here, which says that clockwise moments must equal anti-clockwise moments for such objects. So the clockwise moment is being produced by the beaker here, and we know that it would be weight of the beaker multiplied by the distance of the beaker from the pivot. Similarly, anti-clockwise moment is being produced by the rule here, which is to the left of the pivot. So it would be weight of the rule multiplied by the distance of the rule from the pivot. Now, weight of the beaker would be mass of the beaker multiplied by uh, the gravitational field strength multiplied by the distance. Similarly, the weight of the rule would be mass of the rule multiplied by again g and multiplied by the distance of the rule from the pivot. Now this g is cancelled on both sides, so we are left with m1 x1 is equal to m2 x2. Now the mass of the beaker was 410 grams, and when we convert it into kilograms, we divide it by 1000 multiplied by the distance of the beaker from the pivot would be, since the pivot is at 80 centimeter mark, so it is 4 centimeter till this side of the beaker, and further 4 till the center of mass of the beaker. So the total distance from the pivot is 8 centimeters. So I'm replacing it here as 8 centimeters. M2 is to be found, and the center of mass of the rule is 30 centimeters away from the pivot. Since the center of mass is at 50 centimeter and the pivot is placed at 80 centimeter, so 80 minus 50 is going to give us 30 centimeter as the distance between the center of mass of the rule and the pivot. So 30 would be used here. Now M2 will be equal to 410 divided by 1000 multiplied by 8 and divided by 30. So the mass of the rule comes out to be 0.11 kilograms here. Question number 2. It says the total mass of a wheelbarrow and its load is 90 kilograms. So this is the total mass of this wheelbarrow and the load placed in it. A worker pushes the wheelbarrow and the load up a plank of length 2 meters. So the length of this plank is 2 meters onto a platform as shown in figure 2.1. The platform is at a height of 0.60 meters above the ground. So this is the height of the plank, which is 0.60 meters above the ground. The worker exerts a force of 290 Newton on the wheelbarrow in the direction in which the wheelbarrow moves. The gravitational field strength G is equal to 10 newtons per kilogram. Calculate the gravitational potential energy gained by the wheelbarrow and its load. Now the gravitational potential energy is given by the formula GPE is equal to mgh. So the mass of the wheelbarrow is given to be 90 kilograms. The value of G which is to be used here is 10, and the height, the vertical height the wheelbarrow is gaining and the load is gaining is 0.60 meters. So the value of h to be used here is 0.60 meters, and when we multiply these values we get the answer as 540 joules in two significant figures. So the energy gained by the wheelbarrow and the load is 540 joules. The next part says the worker pushes the wheelbarrow 2 meters along the plank. Calculate the work done on the wheelbarrow by the worker. Now work done is force multiplied by the distance moved in the direction of the force. And we can see that the force being exerted by the worker on the wheelbarrow is 290 Newton, and the distance covered in the direction of the force is 2 meters. So we are going to use these two values. It would be 290 multiplied by 2.0, and it gives 580 joules as the answer. So the work done is 580 joules here. Suggest one reason why the answer in previous part is not equal to the answer in the first part. Now both parts are giving a different answer. The work done by the worker is 580 joules, but the gravitational potential energy gained by the wheelbarrow and its load is 540 joules. So there is a difference of 40 joules, which is being noted here, that the work done was 40 joules greater than the gravitational potential energy gained by the wheelbarrow. So why is it different? One answer could be that work done against friction is the reason of this difference. So there is friction between the surfaces, and for overcoming that friction, some work done or the energy would be used. So that is why that much work done would be used to overcome the friction, and the remaining work done would be used to increase the gravitational potential energy of the wheelbarrow and the load. The worker finds that walking up the plank pushing the wheelbarrow is even more inefficient than answers in part A. Suggest what is meant by efficiency. So the definitions of efficiency is to be written here, and it is the ratio of useful output energy to the total input energy. And if I try to write it in the form of a formula, then efficiency would be equal to this ratio, where useful energy output would be written in the numerator and total energy input is to be written in the denominator. And if we want to convert it into a percentage, then it would be multiplied by 100% over here. Suggest one reason why this method of lifting the load onto the platform is so inefficient. So one of the reason is that the main purpose is to lift this load, and when the load is being carried in a wheelbarrow, such a massive wheelbarrow, then the wheelbarrow uh, would also be needed to be lifted over the plank. And similarly, when some human being is lifting this arrangement or moving this arrangement, then his own weight is to be carried over the plank. So there are two massive extra objects being needed to be carried over the plank. One is wheelbarrow and one is this lifter or the worker. So this method requires a lot of input energy, and it is so inefficient that along with the load, there are two main objects or massive objects which are to be lifted. So one reason could be that wheelbarrow and the worker also are to be lifted. Question number 3 says figure 3.1 shows a hot water tank contains two electric heaters X and Y. This is the hot water heater. We have cold water coming in from this side. There is a heater Y. there is another heater X, and this is the insulation of the electric water heater, and the hot water goes out from this outlet. Heater X is used during the daytime, but heater Y is only used at night when electricity is cheaper. So normally heater X is being used in the daytime, and heater Y only used when uh, it is needed to be used at night when the electricity is cheaper. The tank is full of cold water and X is switched on. The temperature of all the water above X increases very quickly, but the temperature of the water below X increases much more slowly. Explain the process that causes the water above X to increase in temperature. The water above X is receiving heat energy from this heater, and when the water particles or the water receives energy, initially they expand. And expansion means their volume is increasing, so it means their density decreases. And these low density particles, they rise to the top part or the further upper portion of the heater, and the molecules which are not heated, their density is higher, so they move down to replace these particles. This is the phenomena which happens here, and it is called the convection. So the first thing which happens is that expansion of water happens, it is heated. This is the first point. Then density of this water decreases, so it rises, and cold water falls to the region near the heater, and a convection current is established. That is why the water which is above X is heated much more quickly than the water below the heater X. Heater Y remains switched off. Explain why the temperature of the water below heater X increases much more slowly than the temperature of the water above heater X. Now the water which is below this heater, their molecules would receive energy, and they could only pass this energy to their neighboring particles by a process called conduction. When they hit those molecules or particles or their neighboring particles, they transfer this energy to their neighboring particles. And they, when collide with their neighboring particles, they transfer this energy to them. And this process is called conduction, where particles or the molecules do not change their position, they pass on their energy to the neighboring particles by colliding with them. And the process of conduction is very inefficient in liquids, since there are relatively larger gaps in the liquids than solids, and the particles, they are not efficiently connected with the other particles. So the process of conduction is inefficient. The energy transfer or the heat transfer takes place very inefficiently or slowly. So this is what we have to explain it here, and there are 2 marks for this answer. So the first thing, water below X is heated by conduction. There is no convection current establishing here. And conduction is inefficient because water is a poor conductor. The water, being a poor conductor, does not conduct heat energy very efficiently. The next part says the hot water tank is covered in a thick layer of insulating material. The material is a plastic that contains a large number of small pockets of trapped air. Explain why this material is a good insulator. Insulation is being made in such a way that there are pockets which contains air in the insulating layer, and the presence of air makes it a better insulator because air is a slow or a very poor thermal conductor. So heat is relatively trapped better inside the heater. So since the material is a plastic and it also contains small pockets of trapped air, so these two in combined are poor conductors. There are no free electrons in plastic. That is why it is a poor conductor. And trapping air also prevents convection in air. Since the air is trapped and it cannot change its position, so the heat energy to the external air could not be transferred easily. So these are the reasons why this arrangement makes up plastic combining with small pockets of trapped air makes a very good insulator for this type of application. Describe in terms of molecules the structure of a solid. So solid's structure is such a way that the particles are fixed in their positions. They cannot move. Molecules are present in lattice or a particular regular arrangement, and the molecules are closely packed together, tightly packed together. So these are the three things which are to be mentioned for a 3 marks answer here. So I'm writing first thing, molecules are tightly packed and hold fixed places or positions. They are arranged in lattice or regular arrangements. So their intermolecular forces are very strong, which make them to be residing or arranged in a regular pattern, which forms lattice. Figure 4.1 shows a metal worker heating a horseshoe to a high temperature before shaping it. So this is the horseshoe being heated over here. The metal worker then cools the horseshoe by dropping it into 8 kilograms of water at 18 degrees centigrade. The final temperature of the water is 43 degrees centigrade because the horseshoe is transferring heat energy to the water. The specific heat capacity of water. The specific heat capacity is the amount of energy which is required to raise 1 kilogram of a substance. So it is for water 4200 joules per kilogram per degree centigrade. Calculate the thermal energy transferred to the water as the horseshoe cools and loses its energy to the water. Now the energy transfers formula is Q is equal to mc delta T. The mass of the water here is 8.0 kilograms. The specific heat capacity for water is given to be 4200, and the change in temperature taking place is 43 minus 18. Initially, the water was at 18 degrees centigrade and then its temperature raised to 43 degrees centigrade. So this becomes 8.0 into 4200 into 25 degree centigrade as the temperature change, and the answer is 8.4 into 10 raised to 5 joules in two significant figure expressed in standard form. So I'm writing 8.4 into 10 raised to 5 joules. The heat capacity of the horseshoe is 850 joules per degree centigrade. Heat capacity is the amount of heat energy required to raise quantity of a substance, any given quantity of a substance by 1 degree centigrade, and it is represented by capital C. Small c represents specific heat capacity, which was given to be here, and it is the amount of energy required to raise the temperature of 1 kilogram of a substance, and heat capacity is the amount of energy required to raise the temperature of any given quantity of a substance by 1 degree centigrade. Calculate the temperature of the horseshoe immediately before it is dropped into water. So the formula for heat capacity is capital C multiplied by delta T or delta theta, the change in temperature. Now, change in temperature would be equal to heat energy transferred divided by capital C. Now, heat energy transferred by the horseshoe or the heat energy received by the water is 8.4 into 10 raised to 5. The energy which was lost by the horseshoe was gained by the water, and it would be divided by the value of heat capacity. Now, if we round off this answer, this would become 988 degree centigrade here. Now, this is the temperature change which is taking place for horseshoe, and it is losing heat to water. And we know that finally the temperature of the mixture in which the horseshoe and the water is present is 43 degrees centigrade. So we have to find the initial temperature immediately before it is dropped into the water for the horseshoe. So here I would write change in temperature would be final temperature minus initial temperature. Now, normally the final temperature is larger and the initial temperature is lesser if the temperature change is positive. In this particular case, we know that initial temperature of horseshoe was larger and it was losing heat to water, so the final temperature would be lesser. So this change in temperature should be taken as negative, or we could just do that. We could take the initial temperature first and then subtract the lesser final temperature from it. So change in temperature, if taken as positive, would be 988. The initial temperature we have to find, the final temperature was 43. So initial temperature would be 988 plus 43. So it becomes 1031 degrees centigrade. Now this answer is, although in four significant figure, but according to mark scheme, it is acceptable in this situation. And if someone rounds it off to 1030 degrees centigrade, that is also acceptable. And if converting this into two significant figure and making it into 1000 degrees centigrade, this answer is also acceptable here. So whatever the three values obtained written in the answer would be acceptable for this particular question. So the question ends here with this part. The next question says the cable of a washing machine contains three separate wires. There is a fuse in one of the wires. Explain how the earth wire and the fuse work together to make washing machine safer. So there are two things. There are three separate wires which contains a grounded wire or earth wire, and then there is a fuse in one of the wire, and fuse is always connected in live wire. Now both of them play their role in the protection of the instrument or the washing machine. The first thing, what is the function of the earth wire? If the live wire touches the body of the machine, The current is grounded by the earth wire. This is one way of the protection. Similarly, if there are overcurrents in live wire, then the fuse melts or disconnects the supply. So this is another protection which is because of the fuse present in the live wire. State the name of the wire in which fuse is connected. So it is always connected in live wire. Explain why the fuse is connected into the live wire. When fuse is melted, the live wire is not connected to the high potential. So for disconnecting the device from the high potential, we connect the fuse into the live wire. The cable of a hairdryer contains only two wires. State the name of each of these wires. So one of them would be live wire and the other one would be neutral wire. And if there is third wire present, then that is the earth or the ground wire. Suggest why the dryer does not need an earth wire. So the reason is there would be double insulation, or the casing would be plastic, and it is a poor conductor. So for devices like these where normally not a very high current is flowing, earth wire is not needed. Simply double insulation or making the plastic body would be sufficient for the protection purposes. The next question related to the nuclear physics. Phosphorus 32 is an isotope of phosphorus that undergoes radioactive decay. The most common isotope of phosphorus is phosphorus 31. Describe the structure and the composition of a neutral atom of phosphorus 31. Now, the structure of the atoms, and that is very similar in all the atoms. And composition means we have to describe how many particles are present in the nucleus and around the nucleus. We have to describe the composition for phosphorus 31. The proton number for phosphorus is 15 and the nucleon number for phosphorus is 31, which goes on to show that phosphorus contains 15 protons, 15 electrons, and there are 31 minus 15, 16 neutrons present in the nucleus. So I'm describing all this information. First, the composition. There are 15 protons and 16 neutrons in the nucleus of phosphorus. There are 15 electrons surrounding the nucleus. Now, in these two sentences, we have described the composition and also the structure of the neutral atom of phosphorus 31. State how an atom of phosphorus 32 differs from an atom of phosphorus 31. So, there is one more neutron in phosphorus 32 as compared to phosphorus 31. Phosphorus 32 decays by beta particle emission to a stable isotope of sulfur. The half-life for this decay is 2 weeks. State how a nucleus of this isotope of sulfur is different to a nucleus of phosphorus 32. Now phosphorus 32 means we have the proton number of 15 and the mass number of 32. And when this would emit a beta particle, so beta has a charge number of -1 and mass number of 0. Since its mass is negligible and it has a negative charge, a new element sulfur would be formed. Now, as in all beta decays, the proton number would raise by 1. So it would become 16 and the mass number would remain the same. So it would be 32. Now, the details of the sulfur are 16 protons, then it means we have 16 electrons, and for the neutrons we have 32 minus 16 equals 16 neutrons. So this is the composition of a sulfur atom. Now for phosphorus 15, we had 15 protons, 15 electrons, and the neutrons here were 17. So we can see that the proton number from 15 has increased to 16. So there is an extra or more proton present in sulfur, while the neutrons were 17 and now they have become 16. So neutron have decreased by 1. So now I'm writing the answer. State how a nucleus of this isotope of sulfur is different to a nucleus of phosphorus 32. It has one more proton and one fewer neutron than phosphorus 32. So one more proton means the protons have increased from 15 to 16, and one fewer neutron means originally the neutron were 17 in phosphorus, now they have become 16. At time t is equal to 0, a radioactive sample contains 3.2 10 raised to 11 atoms of phosphorus 32. So initially, this much atoms of phosphorus 32 are present. At the same moment, the sample contains no atoms of sulfur. So all the atoms of phosphorus were present and there was not a single atom of sulfur. This is shown by the cross on figure 6.1. So this is the cross which is showing that number of sulfur atoms at time is t is equal to 0 are 0. There is no atom of sulfur atom present. On figure 6.1, plot a graph to show how the total number of sulfur atoms in the sample changes with t or with the variation in time, and draw a suitable curve. Now since the half-life of phosphorus 2 is given to be 2 weeks, so it means that initially there would be 3.2 into 10 raised to 11 atoms of phosphorus as given in the question, and they would start decaying, and after 2 weeks this would be halved. So 1.6 into 10 raised to 11 atoms would be remaining for phosphorus, and similarly the decayed atoms would have been converted into sulfur. So sulfur's number would increase from 0 to this much after 2 weeks, after one half-life. Then after second half-life, this would again decrease and it would become 0.8 into 10 raised to 11, and similarly this would increase by this number. So it would become 2.4 into 10 raised to 11. The number of atoms which are decreasing in phosphorus, the same number of atoms for sulfur would be increasing. So after 2 weeks, I would be marking a dot or a point at 1.6. So it should be marked over here after 2 weeks, and after 4 weeks it should be marked at 2.4 into 10 raised to 11. Now after further 2 weeks, this becomes 0.4 into 10 raised to 11. It becomes further half, and the quantity which was decreased would be added over here. So it becomes 2.8 into 11. So the next point would be 2.8 into 10 raised to 11. And after 8 weeks, finally, this would further decrease and become half. So it becomes 0.2 into 10 raised to 11. And this would increase by the same quantity. So it would become 3.0 into 10 raised to 11. So for sulfur, after 8 weeks, the point would be marked at 3.0 10 raised to 11. And now connecting all these points, we have to draw a curve. So this would be the curve joining all these points, starting from origin, connecting all the points till the very last point. The last part says, state 2 precautions taken when storing or moving radioactive material. So one is minimum exposure time. Should be ensured that we are not exposed to radioactive materials for longer period of time. And lead shielding, like lead apron, gloves, or glasses, they should be used. So this question says, a bus leaves a bus stop at t is equal to 0 and travels along a horizontal road until it reaches a second bus stop. Figure 7.1 is the distance time graph for the bus between t is equal to 0 and t is equal to 60 seconds. So in the graph, we can see that there is distance on the y-axis, time on the x-axis, so it is a distance time graph. Here, the bus is leaving the first stop, and here the bus has reached the second bus stop, and after which the graph has straightened or become horizontal. So means the value of the distance is not changing, and when it is not changing, it means the bus is not moving. Okay, the road on which the bus is traveling is straight except for a short curved section. So almost all the road is straight, which means the direction of the bus would not be changing except for a short curved section. The bus travels around this circular curve between t is equal to 21 to t is equal to 24 seconds. So this is where the direction of the bus would have been changing. Describe how the motion of the bus between t is equal to 0 and t is equal to 10 seconds differs from its motion between t is equal to 35 and t is equal to 40 seconds. Now if we look at the first portion, this is the first portion, so we can see that we have a curve over here, and this curve is of increasing gradient. So in a distance time graph, we know that the gradient represents the speed of the object. So when we have an increasing gradient, means speed is increasing, and when the speed increases, we have acceleration in the body. So it is the accelerated movement. Now if we look at the graph at t is equal to 35 to 40 seconds, it is again a curve, but this time it is a decreasing gradient curve. So it means that gradient or the speed must be decreasing. And when the speed is decreasing, we have deceleration in the moving object. So this is how we can explain their difference. We have to write a 3-mark answer over here. So I'm writing between t is equal to 0 and t is equal to 10 seconds, we have a curve of increasing gradient, which means speed is increasing and bus is accelerating. Between t is equal to 35 and t is equal to 40 seconds, there is a curve of decreasing gradient. So speed is decreasing and the object is decelerating. So this is a 2-mark answer. Now there is a 3rd mark. So we have to write another point. So the 3rd point could be it starts from rest and speeds up between t is equal to 0 to 10 seconds, and it ends up being at rest at t is equal to 40 seconds as the graph became perfectly horizontal um, when the bus reached a t is equal to 40-second mark. And in the initial portion, it is starting at rest. So initially, there was a horizontal portion in the graph, and then it started increasing. So means that it started to speed up from after starting from rest. The next part says determine the maximum speed of the bus during these 60 seconds. Now, the maximum speed is shown by the maximum gradient, and the maximum gradient is when the graph is having this straight line portion. Now, for finding the maximum speed, we could consider any 2 points on this graph. For example, this point, it has a x coordinate of 20 and y coordinate of 180. Similarly, this point has an x coordinate of 30 and y coordinate of 300. So we could use these 2 points, find the gradient of this line, and that gradient would show us the maximum speed of this moving bus. So I'm noting it down here. Now m is equal to, or the gradient is equal to y2 minus y1 upon x2 minus x1. So this would become 300 minus 180 divided by 30 minus 20. It is 120 upon 10. Answer is 12 meters per second. So the maximum speed that the bus obtained was 12 meters per second. The average speed of the bus between leaving the first bus stop and arriving at the second bus stop. Now, we have to find the average speed between leaving the first bus stop and arriving at the second bus stop. Now, the time for leaving the first bus stop is t is equal to 0 seconds, and the time for arriving at the second bus stop is t is equal to 40 seconds. So we can see that the bus left the first bus stop at this moment and reached the second bus stop at this moment. So there is an interval of 40 seconds between these two things. Secondly, if we check out the total distance covered by the bus, then it would be this much. So it is a value of 390 meters, or the distance was 390. First, I would be writing the formula. and this would be average speed of an object is equal to total distance divided by the total time. Total distance is 390 divided by the total time of 40. So it becomes 9.75, or I could round it off to 9.8 meters per second. So the average speed of the bus during this journey was 9.8 meters per second. State how velocity differs from speed. So velocity is a vector, while speed is a scalar. Scalars do not have any direction. Velocity, being a vector, has a direction also. There are 3 periods during the 60 seconds where there is non-zero resulting force. Non-zero resulting force means there must be acceleration in the object or the moving object. When the resultant force is zero, there is no acceleration in the moving object. So there is a non-zero resultant force acting on the bus. Complete the statements to indicate these 3 time periods and state the direction of the resultant force in that period. So the first period was, we saw that from t is equal to 0 to 10 seconds, we could see that there was an increasing gradient, which means the bus was accelerating. So when the acceleration is happening, it means there is non-zero resulting force. Secondly, from t is equal to 35 to 40 seconds, we saw that speed was decreasing, so the object was decelerating. It means there was a non-zero resulting force which was stopping the bus or decreasing its speed. And then we were given with the information that the bus travels around a circular curve between t is equal to 21 to t is equal to 24 seconds. So this becomes t is equal to 21, and this becomes t is equal to 24. So during this time, the bus was moving or going through a curve. So when an object is going through a curve, it is following a part of the circular part or the circular path on which it is moving. And when something is moving in a circle, the resultant force is always directed towards the center of the circle, or it is perpendicular to the motion or the direction of movement. So we are going to mention these 3 parts here. Between t is equal to 0 and t is equal to 10 seconds, the direction of the resultant force is forwards because it is accelerating, or we could write it down as in the direction of the movement of the bus. So the direction in which the bus is moving, in the same direction a resultant force is acting. Between t is equal to 21 seconds and t is equal to 24 seconds, the direction of the bus is perpendicular to the direction of movement. The bus is moving with a constant speed, but the direction of movement is changing. So since it is going through a curve like this, so if the bus is moving in this direction along the tangent at any instant, the force would be acting at a perpendicular. So there would be a 90-degree angle between the direction of the force and the direction of movement or the velocity of the object. Between t is equal to 35 seconds and t is equal to 40 seconds, the direction of the force is backwards because the object is decelerating, or we could write it down in the opposite direction of the movement. So opposite to the direction of movement, this could also be written, or simply backwards would be the answer, the complete answer, which should earn us complete marks. During the journey, the air resistance acting on the bus varies. State why the air resistance changes during the journey. So air resistance is dependent on the speed of movement of an object. When the speed is changing, the air resistance is also going to change. So the reason is that speed of the bus changes. That is why the air resistance also changes. On figure 7.1, mark and label with an M a time when the air resistance is a maximum value. So it is maximum when the speed is maximum, and the speed is maximum during 10 seconds to 35 seconds. So anywhere during this, we have to mark a point M. So for example, I'm marking it over here, M, and during this period, the speed is maximum, so the air resistance acting on the bus would also be maximum. It says a thin converging lens is made of a transparent material of refractive index 1.4. A ray of light traveling in air strikes the surface of the lens at an angle of incidence of 55 degrees. Calculate the angle of refraction. We are familiar with the formula that refractive index n is equal to sine I upon sine r. So the value of refractive index is given to be 1.4 for the transparent material, and the angle of incidence is 55. So the angle of refraction is to be found, which would be equal to sine inverse of sine 55 divided by 1.4, and the answer would be 36 degrees. So the angle of refraction is 36 degrees. Place a tick in one of the boxes in the third column of table 8.1 to indicate how the light ray deviates and what happens to the speed of the light in the ray as it enters the lens. Since it is entering a denser medium, lens is a denser medium, optically denser medium, so the speed is going to decrease and it would bend towards the normal. So obviously the light ray is going to bend towards the normal. Now with this we have three options: speed decreases, does not change, increases. So the speed is going to decrease. So we are going to place a tick over here. Speed of light is going to decrease because it has entered into a denser medium and it would bend towards the normal. State what happens to the frequency of the light in the ray as it enters the glass. So there is no change in the frequency. It stays constant. The focal length of a lens is 2.5 centimeter. Of the lens is 2.5 centimeter. State what is meant by the focal length. So it is the distance between the principal focus, or we could also write focal point, and the center of the lens, or the optical center. So distance between the optical center or the center of the lens and the principal focus. Principal focus is found on either side of the lens. So any one of the principal focus and the center of lens, their mutual distance is the focal length of the lens. Figure 8.1 is a full scale diagram that shows an object O of height 3.0 centimeters and the lens. By drawing on figure 8.1, locate and mark the image I of O. Focal length of the lens was given to be 2.5 centimeters. So first of all, we would be marking it on the both sides. And we know that the length of the object is given to be 3 centimeters. So it means that uh, this one box or these 5 small boxes together are representing 1 centimeter, then this is 2 centimeter, and it is 3 centimeter. So for uh, showing a length of 2.5 centimeter, we would take one box here, one division, then the second division or 2 centimeters, and then here would be 2.5 centimeter. So this is the principal focus on one side, and it is the principal focus on the other side. Now for the formation of image, we can use any of the 3 rays. I'm using the first ray, which goes parallel to the principal focus till the lens, and after passing through the lens, it goes from the principal focus. So this is the first ray that I'm using for the image formation. So after passing through the lens, after refracting, it went through the principal focus. Now the second ray that I'm using would be the one which goes through the optical center and continues its path undeviated. So this is the second ray. Now where the two um, rays are joining or intersecting each other, that would be the point where the image would be formed. So it is formed at this point. So a head would be formed here and eye would be indicated here. Now, if we just look at the height of the image, the height of the image is approximately 1.2 centimeters. The next part says determine the distance of image from the lens and calculate the magnification of O produced by the lens. So the distance of image is 1, 2, 3, and a little after 3.4. So it could be taken as 3.45. So I'm writing it is 3.45 centimeters. Now we have to calculate the magnification. Magnification is given by height of image divided by height of object. Or there is another formula which could be used. It's actually the distance of image divided by the distance of the object. So we can use any one of them. So if we use the first one, the height of the image is 1.2 and the height of the object is 3.0, 0.4. And to make it into significant figure, I'm writing 0.40. So 0.40, and it does not have any unit, is the linear magnification in this. And we could also use the distance of the image divided by the distance of the object from the lens, and that would also give us the same answer. The last part of the question says describe how a converging lens is used in a camera. Okay, so the camera is used for taking images, and for taking this image on a screen we have to form a real image. So the first thing that we do in a camera is that the light coming from the object is focused by adjusting the lens so that a real image is formed on the film. So when the real image is formed on the film, that is printed and used as the image taken by the camera. Question number 9 says figure 9.1 shows a permanent magnet lying on a piece of paper. So this is the piece of paper and it is the permanent magnet lying on this paper. Underline the material in the list from which it is possible to make a strong permanent magnet. So a strong permanent magnet is made using a steel. Describe an experiment to plot the pattern and the direction of the magnetic field surrounding the magnet. You may draw on figure 9.1 if you wish. So the first thing is uh, a plotting compass or the magnetic compass is to be used. So for example, the compass is placed here near this end to check whether it is a south pole or a north pole. So the compass is pointing like this away from the pole. So it means that it is the north pole and this is going to be the south pole. Now the direction in which the compass is pointing, a dot would be made, and then the compass would be placed again such that the tail of the magnetic compass needle is aligned with the dot, and the direction in which the arrow is pointing, another dot would be made. And then again, the compass would be used, aligning the tail of the arrow with the dot, and the direction in which the arrow is pointing, a dot would be made. And this process would be repeated such that we obtained many dots, and starting from one end, we reach to the other end. And when we connect these dots, we get a loop, and the direction shown by the arrow of the magnetic compass, it would be the same as the direction of the magnetic field. And this process is repeated several times so that many loops are drawn. And this is how the magnetic field of a permanent magnet is drawn using this plotting compass. I'm writing the answer. A plotting compass would be used by placing it next to the magnet. A dot would be marked where the needle points. The compass would be moved so that the tail of the needle is aligned with the dot, and the next dot would be marked where the needle points. The marking continues and loops or lines would be drawn. The needle points in the direction of magnetic field. So this is the description of the experiment uh, with which we can find out the direction of the magnetic field. Other way of doing it could be using the iron fillings, and they could also be used to draw the pattern of the magnetic field around a permanent magnet. The next part says figure 9.2 shows the north pole of a magnet placed in front of the south pole of a second magnet. Now this is the north pole and this is the south pole. A section of a horizontal metal wire JK lies in the magnetic field between the two magnetic poles. So this is the section of the wire. End K of the metal wire is connected to positive terminal of a battery and end J is connected to the negative terminal. So this is the positive terminal connected end of the wire and this is connected to the negative terminal of the battery. So it means that a current would start flowing through this wire in this direction. The direction of the conventional current would be to the left. Explain in terms of electrons why there is a current in the wire and state the direction of the conventional current. So the currents flowing is to be explained in terms of electrons. And secondly, the direction of the conventional current is to be mentioned here. Since this end is connected to the positive terminal and this end is connected to the negative terminal, so the free electrons present in the wire would be attracted towards the positive end and would be repelled from the negative end. So they would start flowing in this direction in the wire. But the conventional current is the current which flows opposite of this movement. So that would be from positive to negative. So conventional current would be from positive to negative in the left direction, and the electron flow would be from left to right direction, from away from the negative polarity and towards the positive polarity. So I'm writing free electrons are attracted to positive terminal and repelled by negative terminal and move to the right, while conventional current flows from K to J. Since K is at positive polarity and J is negative, so the conventional current would flow like this. The part of Jk that is in the magnetic field experiences a force F. So this is what we call the motor effect, that whenever a current carrying wire or a conductor is placed in a magnetic field, a force acts on the conductor because of the interaction of both magnetic field. State the direction of F and describe how this direction is deduced. Okay, so the direction is deduced by using the Fleming left-hand rule. So in generators, right-hand rule is used, and in motors or motor effect, the Fleming left hand is used. Index finger points in the direction of magnetic field. Then second finger is aligned with the current, and thumb gives the direction of F, the force exerted on the conductor. Now, in this case, the magnetic field is from north to pole. It is always from north to pole. So the first finger would be aligned into the page. Then the conventional current is to the right. So the second finger would be aligned towards the right, and thumb is pointing downwards. So it means that a force in the downward direction would be experienced by this conductor. So I'm writing the direction. The direction of F is downwards or down the page in the above scenario. So this is how we can find the direction of the force acting on the conductor. Now, the next part says the equipment in figure 9.2 is used in a similar experiment. The part of JK that lies between the poles of the magnet now passes through a long iron tube. So a long iron tube is surrounding the wire that is fixed in position and it cannot move. The tube is shown in figure 9.3. JK is connected to the battery in the same way as before. State what happens to the force F on the wire. Explain your answer. Since the wire is placed in an iron tube, so iron is a material which provides a very convenient path for the magnetic field lines to pass. So all the magnetic field lines would pass through the iron material coming from North Pole and would go towards the South Pole. And no magnetic field or field lines would interact with the wire. So since there is no interaction of the magnetic field lines, so there is no force acting on the wire JK. So I'm writing there is no force F on the wire, and the reason for this is that because the wire is magnetically shielded by the iron tube. So iron tube is the material from where the magnetic field lines would be passing, and there would be no interaction between the two magnetic fields now. The next part says the iron tube and the wire are removed. A square vertical coil is placed between the poles. This is the square vertical coil, so that the plane of the coil lies in the magnetic field in figure 9 point as shown in figure 9.4. So this is the coil now, and north pole, south pole. Now the square coil is placed in the magnetic field. Explain why the coil tries to rotate when there is a current in the coil. Again, this is because of the motor effect. So the first thing is when there is current in the coil, when a current flows through the coil, there is a magnetic field around the coil also, and since it is placed in the magnetic field of another magnet, so both the magnetic fields interact, and there is a force on the coil which tries to rotate it, which tries to create a moment in the coil. So the first thing is coil produces a magnetic field around it. The magnetic field interacts this magnetic field interacts with the magnetic field of the permanent magnet and force acts on the coil such that opposite poles of the two fields attract and like poles repel, producing a moment in the coil. So that is why it tries to rotate when it is placed in a magnetic field.